to take the mic.
Hey everyone, thanks for having me here. I'm excited to talk to you all today. Again, my name is Rotem Sagi. I'm a user experience researcher working in tech for over 10 years now. I focus on trust and safety related research. Um, I've worked across a variety of large tech companies on a bunch of different types of products and experiences, using different kinds of research methods to understand what are some of the unintended bad experiences that might come with different technologies and internet services, develop solutions to mitigate those bad experiences, and identify new opportunities to create safer, more trustworthy online experiences. Um, I am here today talking as myself, not on behalf of any of these companies. So these are just my personal views and opinions, having worked in this space and seeing some of these technologies develop over the years. So getting into it, as Erin mentioned, wanting to start off with just a pretty big, broad overview of AIs. What is it we're talking about? What are these models doing? I think for me, that's really where a lot of the information gets lost along the way when we're talking about some of this stuff. So some of you may know this. This may be new to some of you, but the goal here is to just really understand what it is we're talking about and get on kind of the same page. So taking a step back, um, AI is really a broad category, more of a marketing term than it is a technical category of any sort. Over the years, we've used AI to refer to a lot of different kinds of advanced mathematical models. Today, we're often using AI to refer to LLMs or large language models, which is one type of machine learning model. Before LLMs were popular, uh, machine learning was the big thing, and we use that to refer to that as AI or the algorithm. We've been using ML models in a lot of different online applications. Before LLMs, we were using other kinds of machine learning models. Today, we use a mix of different types of models for a really broad range of applications. They're used to determine what kind of results are shown when people use popular search engines, what kind of products are surfaced when people are doing online shopping, what kinds of content and the order in which the content is shown on social media. It's used heavily in online advertising and how to target ads to different users. It's also used to help people in a lot of ways. It's used in customer support to solve people's problems. We use these technologies to help verify people's identity, identify fraud, try to stop scams. It's used a lot in the financial sector. Surveys show that people are often unaware of when and how ML or AI is used to power the systems they rely on, but these things are embedded throughout the technologies we commonly rely on today. I want to kind of talk through a couple of just key terms and concepts you might have heard about. Some of you may be more or less familiar with these, just so we're kind of on the same page when we're talking about some of these models. So just right off the bat, LLM, large language model, it's a type of generative model that is designed to understand, process, and generate human-like text. So this is a model that is really based on language as opposed to some of our other models, which may be focused on other types of applications. Token is the basic unit of text or code that a large language model reads and generates. A token could be a word or a part of a word. When you give an LLM a prompt, it will break the prompt down into tokens. And when it is generating responses, it will predict which tokens to generate given all of the inputs and trainings. Non-deterministic, you may have heard this in reference to LLMs. It's really common throughout a lot of different kinds of machine learning models. It means that an LLM can be given the same prompt and provide different outputs. This is by design. There's always a level of randomness in the outputs generated by LLMs, as you can imagine. This makes it harder to test, and it also creates some additional risks we'll touch on a little bit. These models are probabilistic, meaning they generate a response. When they're generating the responses, they're assigning different tokens, different kinds of probabilities to figure out which token or word should be shown next in the sentence or sequence of words. So the next token or word in a sentence isn't guaranteed. It's just a probability the model calculated based on how it was trained. And finally, black box. You may have heard this in reference to some of these AI tools. When we talk about black box, what we mean is the math underpinning these models is extremely complex, and we can't decipher it directly. Similar to other kinds of ML models that we've been using for many, many years now, we don't know for sure what information the LLM is using or how it's making decisions. We don't know for sure what probability was assigned to each option before it showed us the output. We only know what input we provided and what output it generated. So taken together, LLMs are kind of trying to guess what word or token will come next in a sequence. And we don't know for sure in every situation why it picks a certain word. And there's no guarantee that the same inputs will always result in the same outputs that the LLM shows us. So it's important to remember, it's not magic. They're really impressive tools, but it's just math. Really cool math, really effective math, but it's just math that is designed to respond in a way that seems like something a human might say. So just like their ML predecessors, LLMs are built by humans. They're a tool that can be useful, but like anything humans have built, they have flaws, and they're built with our own biases, whether we meant to or not. They're built by providing a lot of training data and running these models through various tests and then refining the LLM until it gets better and better at passing its tests. At a very high level, LLMs are really complex and they're trained to respond in a way that seems like something a human might say, but they don't think in the same way that humans think. Instead, they calculate the probability of the next word or token in a sequence. And it's important to remember that these tools are only as good as the training data we provide and the quality of tests that we give it. So to just take a moment on this, when we're talking about training data, LLMs require a lot of training data, which means we're not feeding these models the highest quality information from exclusively vetted sources. Models are typically being trained on as much data as possible. This includes classic literature, peer-reviewed journal articles, personal blogs, internet forums, and even Slack messages like private internal business messaging platforms employers provide employees to message each other. Companies are constantly looking for more sources of data to train the models in order to improve them. And then we often run tests. The black box nature of the model means we can't always see what's going on under the hood. The math is really complex, involves a lot of parallel calculations. So to understand why a model is performing in a specific way, or to assess any potential risks, biases, things like that, we humans develop tests to assess the model. The same way teachers and educators use tests to assess students, we use tests to assess model performance. But just like a test doesn't always tell us why a student may not be performing like we would expect, the tests we give models only give us a glimpse into what the model may not be doing, why the model may not be doing what we expect. It doesn't always tell us why. These tests are designed by humans and are always as good as the test makers. And because the models are non-deterministic, we can't predict how it will respond in every single situation. And just because it responded one way to one particular test doesn't mean it will respond that way 100% of the time. And all of these taken together create some potential risks. I want to briefly touch on some of them. So like any new technology, There are a lot of benefits, especially in some of the research space, some of the accessibility space. These are really powerful tools, but like any new technology, they can also introduce new risks or even exacerbate existing issues. This is just a glimpse of some of the risks. It's a broad mix of things that some of them may be more specific to LLMs and AI, while others are existing risks we've been trying to manage for many, many years, and it may be exacerbated by LLMs. Um, uh, Even the most rigorously tested AI can produce problematic responses. Like with any new technology, there's no amount of guardrails that can fully guarantee an AI will act any specific way. We don't have time to talk about all of these risks. So I want to talk about just a couple with you today. So I really want to focus mostly on privacy and data security. And there's a lot here, so we're going to go over this somewhat quickly, but happy to answer further questions about this. So first of all, when it comes to privacy, one thing to be cognizant of when it comes to AI is it could memorize or leak sensitive or personal data. It also is really good at pattern detection, which is great when we're trying to develop new innovative ways to identify cancer, but can be problematic when an LLM may inadvertently infer something private or sensitive about a user without its consent. So, maybe based on the kinds of questions or prompts someone is providing an LLM, it could determine they have some underlying health condition that they didn't intend to provide the AI with that sort of information. Private data can make its way into the data sets AI is trained on. When that happens, because of the black box nature of these LLMs, we don't always know how the model uses that data, and we can't guarantee that information won't show up somewhere down the line, either explicitly or implicitly with how the AI engages with a user or a group of users. When it comes to data security, like I've mentioned, no system is 100% sure, 100% secure. This is kind of just a universal security concept. AI makes it easier for malicious actors to find vulnerabilities and exploit systems. It also provides new avenues for cybersecurity attacks. So even if someone is promising you to keep your data completely private, they could potentially suffer a security breach. Most security vulnerabilities come from people just being people, just like the best locks that aim to secure a building can easily be overcome by someone innocently holding a door open for someone walking in behind them. It often only takes one person in an organization making an innocent mistake in order for a security breach to happen. One person clicks on a phishing email, someone leaves their laptop open at a coffee shop while they run into the restroom. There's just no such thing as 100% secure system because people are people. And finally, anonymization. So in the past, one of the ways, because we know things can't be 100% secure, one of the ways we've tried to protect people's privacy is by making their data anonymous. When we're talking about anonymization, what this often means is removing what we call personally identifiable information or replacing it with maybe a random ID. So we take some data from a large group of users, we remove the information that can link those individuals to back to the information they provided to anonymize the data. However, AI is actually really good at pattern detection. So these previous efforts, these strategies we've used to make data anonymous is getting harder and harder to do because AI can infer that connection back to the user, whether we intended to, so malicious actor can use it to infer that, or it may unintentionally happen based on the AI trying to make other kinds of connections or detect other broader patterns in a system. Another thing that's happening right now, as with any big technological boom, there's a lot more third-party sellers in the space. A lot of people are here building new tools and technologies, many of which are aimed at AI tools used in education. As Erin mentioned, there's a lot of tools and money in the space. Something to be aware of as you're hearing more about these tools: the vast majority of these tools sold in this space are built on top of the commercial LLM models. Developing, building, and maintaining an LLM model is a lot of work. It's really challenging. It requires a ton of resources. Most of the tools you're likely interacting with are companies taking an existing tool like ChatGPT, um, adjusting it, either kind of refining it slightly for a specific educational purpose, maybe making a new user interface to make it easier to use in certain ways, and then providing it back to the end user, the customer. What that means is any biases or issues with the underlying model is also present in the tools being sold by third-party providers. So any issues that ChatGPT may be experiencing means that those issues will show up down the line in any third-party tools that run on ChatGPT. This also means that because you have kind of a third party thrown into the mix, this could add additional issues related to bias, accuracy, privacy, or inconsistency, depending on how this third party is refining and updating and changing the UI for the tool. I also wanted to mention, I've worked in the tech space. I'm really passionate about technology. I think it can be really powerful. I've worked in the accessibility space. These tools can be helpful in a lot of ways. But just like all tools and machines, it's important to remember that it is a tool, like a calculator is a tool. But it's the people at the end of the day that create ideas and add value. It's really the labor that creates value, not the tool itself. So in the same way that calculators helped us do more complex math more quickly, and then computers helped us do more and more advanced and complex math, really powerful tools. But at the end of the day, it's actually people doing the math, applying the ideas, and developing innovations. And these tools are here to help facilitate that work. As Erin mentioned, there's a lot of research coming out right now. There's not clear evidence that AI is providing the promised productivity gains for knowledge workers. In some cases, it may even be slowing people down because they're spending so much extra time trying to fix errors and bugs and accuracy, editing down and refining things. So it's not clear that it's 100% always providing the productivity gains that are being promised. And there's increasingly more and more results about whether or not AI is actually improving educational outcomes for students. We're not seeing a lot of clear evidence that it is, the surefire ticket to help make everyone more effective and productive. So being really thoughtful about how we're using it and what we're trying to solve using this tool, in the same way that using calculators in the classroom didn't destroy our students' ability to do math, but how we use calculators to do math is important, as long as we're still teaching math at the end of the day. Be aware of anyone who's guaranteeing accuracy or a completely unbiased, risk-free tool. As I've kind of pointed out, they're non-deterministic, so you can't really make these guarantees that is 100% completely free from bias or it is 100% accurate. Also be aware of companies that may be claiming they have custom-built AI tools. Again, these are really hard things to build and maintain, require a lot of processing power and information. Most of what you're seeing out there on the market is actually third-party tools that are built on top of the commercial tools. And finally, be aware of anyone who is guaranteeing privacy or safety. Safety is not something that you can always reasonably guarantee in most cases. So vendors who are claiming to protect privacy by removing names and student ID numbers, remember that it's increasingly easier to reconnect students with the information we've provided about them. And so, what should you do when you are being surfaced these sales tactics? Well, the best thing to do is to be curious, ask questions. So, someone is guaranteeing accuracy or a completely unbiased, risk free model. Like I mentioned, we test the models. How are they testing the models? What is the rate of hallucination or error? How often is the model making an error? It's probably not 0%. There's probably some percent of error or bias or hallucination. A common thing we'll talk about in the space is kind of false positive rate. So when we're running a test, how often is it getting the test wrong? How are they measuring bias and errors? There's a lot of different kinds of bias out there. As someone who's spent time researching different kinds of biases, especially in new technologies, there's a lot of different kind of biases. What are they doing to measure and test that? When companies are claiming to have custom built AI tools, really kind of drilling down, are they using existing commercial tools, or did the company train, host, and maintain its own dedicated infrastructure? If they are using a commercial tool, which makes sense because those tools are robust and built with a lot of technical expertise, what data is shared back with the commercial tool provider? If a company is using ChatGPT to run their educational software, what data are they sharing back with OpenAI? What happens if ChatGPT goes down? What happens to your third-party tool? These tools, these commercial tools are getting updated regularly. We're making a lot of advances in this technology, which means that as the underlying commercial companies are updating the tools, coming out with new versions, the tool will respond slightly differently each time. So what happens if, say, ChatGPT updates their model? How is your third-party company handling that? Are they immediately updating it? Are they testing it? What can you expect as far as how your new tool is going to respond every time OpenAI or Google or Anthropic updates their own tools? And finally, when companies are promising privacy or safety guarantees, how are they ensuring that data privacy? What data are they collecting, and how and where is it stored? Do they know? Can they pinpoint where in the pipeline the data is being stored and collected? And can you get a guarantee that the data is walled off from any potential training sets? And that if for any reason you decide to end your contract, that data can be instantly deleted. It's a lot harder to do than you would think. And so getting a guarantee like that can be really powerful in this case.